Welcome back, dear children. Now we will move to question number 17. A body of mass 10 kilogram. So mass is given as 10 kilogram is moving with a velocity of 20 meter per second. Velocity is given as 20 meter per second. If the mass of the body is doubled and its velocity is halved, find the initial kinetic energy and the final kinetic energy. So first you have to do or calculate the kinetic energy with the given values. Then after that you have to double the mass and half the velocity. Then you have to solve. Okay. So first initial kinetic energy equal to half mv square. This will be equal to half into 10 into v square, that is 20 into 20. 20 and 2 gets cancelled. Here you will be getting 10. Now 20 into 10 into 10, which is equal to 2000 joule. Now in the second case, that is final kinetic energy is equal to half into what is given in the question. Mass of the body is doubled. So the mass was 10. When it is doubled means it becomes 20. And the velocity is halved. So in the beginning velocity was 20. Now it becomes 10. Halved means it is 10. So 10 into 10. Now this and this cancel. Here it is 10 and our answer will be 1000 joule. So initial kinetic energy means with the initial values. Then after giving the changed values, you can calculate the final kinetic energy. Now question number 18. A truck weighing 1000 kgf. Okay. So the weight is given as 1000 kgf. Changes its speed from 36 km per hour to 72 km per hour in 2 minutes. Okay. So initial velocity is 36 km per hour. How to convert kilometer per hour to meter per second? I have given you a short method. What was that? Just multiply it with 5 by 18, isn't it? So 36 into 5 by 18. When you multiply with 5 by 18, you can convert kilometer per hour to meter per second. So 18 and 36 gets cancelled. 2 into 5 is 10. So initial velocity is 10 meter per second. Now final velocity, it is given as 72 kilometer per hour. So how to convert this? 72 into 5 by 18. 18 into 4 is 72. 8, 16, 24, 32. So then 4 into 5 is 20. We are having 20 meter per second. Now in 2 minutes, that means time will be 2 into 60, which is equal to 120 seconds. Calculate the work done by the engine as well as its power. So in this question we are asked to calculate the work done as well as power. So how will you calculate the work done? So work done means actually according to work energy theorem, work done on a body is equal to the increase in the kinetic energy of the body, isn't it? So according to work energy theorem, work done on a body is equal to increase in its kinetic energy. So increase in its kinetic energy means it is final kinetic energy minus initial kinetic energy. Half into m into, how much is the mass? It is 1000. Okay, kilogram and kilogram force means same thing. Same dimensions for that. kg is the unit for mass, kgf is the gravitational unit of force, but value remains the same. So instead of mass, I am taking 1000 itself. Then V square, that is, it is 20 square minus 10 square. So half into 1000 into, how much is 20 square? It is 400. 10 square is 100. 400 minus 100. So we are having 300 there. So 300. Now 3 divided by 2 is 1.5. How many zeros? 10 raised to 5. So 1.5 into 10 raised to 5 joule. 3 by 2, that is 1.5. Then when you count, 5 zeros are there. So 1.5 joule into 10 raised to 5 joule is the work done. Okay, here I have used the work energy theorem. Work done is equal to increase in the kinetic energy. Now, shall I write this? Then only I can do the next part. One more question is there, that is, we are asked to calculate the power. What is the equation for power? Power is equal to work by time. So work is 1.5 into 10 raised to 5, and time, we have calculated the time as 2 into 60, which is equal to 120. Okay, now how much we have to get here? So do one thing here, 1.5 into 10 raised to 5. Let me write it as 150 into 10 raised to 3. I took 2 zeros from here. So here it becomes 150 divided by 120. 0 and 0 gets cancelled. When you are dividing 15 and 12 with 3, how much here we will get? Here it is 5, here it is 4, isn't it? Now, here it is 5 into 10 raised to 3 means it is actually 5000. 5 into 10 raised to 3 divided by 4. Okay. 5000 divided by 4. When you cancel it with 2, here it will be 2500. Then 2500 divided by 2 is 1250. So 1250 watt. In your textbook it is written as 1.25 into or 1.25 into 10 raised to 3. Means same thing. Okay. So it is 1250 watt. 1.25 into 10 raised to 3 means it is equal to 1250. So we have used the work energy theorem, and here you should not forget to convert minute to second. Okay. Moving to question number 19. A body of mass 60 kilogram. So mass is given as 60 kilogram. Has momentum of P is equal to 3000 kilogram meter per second. Okay, because P is equal to mass into velocity. So the unit is kilogram meter per second. Calculate the kinetic energy and speed of the body. We are asked to calculate the kinetic energy. I told you to underline a relation connecting kinetic energy and momentum. What was that? Yeah. Kinetic energy is equal to P square by 2m. So P is 3000. P square means it is 3000 into 3000 by 2 into 60. If I cancel 2 and 3000, here I will be getting 1500. Then let me cancel these two zeros. Now with 3 if you are with 2 if you are dividing, or with 3 we will do, that will be easy, no? So 6 divided by 3 is 2. 150 divided by 3 is 50. Okay. Here it will be 6 by 3. Okay, 2. Now here it is 150 divided by 3. It is 50. Now 50 divided by 2. 50 divided by 2 is 25. So we will be getting it as 25 into 3000, which is equal to 50 and 2. That is why we are getting 25 here. 25 into 3 is 75. So 75,000 joule will be your answer. Okay. So 75,000 joule is given as 7.5 into 10 raised to 4 joule. Now the next one, you are asked to calculate the velocity, isn't it? The speed of the body. Now we got kinetic energy. P is equal to mv. So what is V? P by m. P is 3000 divided by mass is 60. 0 and 0 gets cancelled. Now 300 divided by 6. How much is 30 divided by 6? It is 5. 1 0 is there. So the answer is 50 meter per second. Okay. Now question number 20. How much work is needed to be done on a ball of mass 50 gram? So mass is given as 50 gram. 50 gram means how many kilogram? 0.05 kilogram. Okay. To give it a momentum of, momentum is given as 5 kilogram meter per second. So how much work is needed? That is what it is asked. So already I told you the work done on a body is equal to the increase in its kinetic energy. So you can use the equation for kinetic energy, or the another thing what you can say is energy and work have same dimensions, isn't it? So work is equal to work or energy. We have the work is equal to kinetic energy is equal to P square by 2m. So direct substitution. Okay. P is 5. So 5 square, 5 into 5. 2 into mass is 0.05. Since decimal place is there in the denominator, with what should you multiply in the numerator and denominator? Since 2 decimal places are there, you have to multiply with the 100, isn't it? Then only you can remove the decimal place. So it is 5 into 5, which is equal to 25 plus 2 zeros. So 2500. Then 0.05 into 10 raised to 2 means it becomes 5. 10 raised to 2 is 100. That means decimal point will shift 2 places towards right. So 100. 2 into 5. 0.05 into 100 is 5. 2 into 5 is 10. So the answer is 250 joule. Okay. So work done. Either you can use the work energy theorem. Work done is equal to increase in kinetic energy. Only one is given there, isn't it? Since velocity is not there, it is better not to use the work energy theorem. You can say that the work done, work and energy are having the same dimensions. So it is equal to P square by 2m. Clear? Now moving to question number 21. How much energy is gained by a box of mass 20 kilogram? So mass is given as 20 kilogram. First question there. Carrying the box waits for 5 minutes for a bus. So this person is carrying the box and he is waiting for the bus. So how much energy is gained? So energy or work means it is force into displacement. Since the person is standing there without the load, is he doing any work? No. Here the person is carrying the box. Person carrying the box waits for 5 minutes for a bus. So this person is standing in the bus stop with this weight. Okay. But in physics he is not doing any work. There is no energy is spent. Why? Because displacement is equal to 0. Now next one. Runs carrying the box with a speed of 3 meter per second. So what is that? If he is running, which energy is possessed by him? For motion, kinetic energy. So we'll calculate the kinetic energy here. Half into 20 into how much is the speed? 3. So 3 square. 2 and 20 gets cancelled. 3 square is 9. 9 into 10, which is equal to 90 joule. When he is running, he possesses kinetic energy. Now, see, he raises the box by 0.5 meter in order to place it inside the box. So, he is raising the box. So, which energy is possessed by him? Potential energy. mgh. Mass is 20. G is given as 10 in the question. Then what about the height? Height is given as 0.5 meter. So with the 0 you can remove the decimal point. So 5 into 20, which is equal to 100 joule. Okay. So it's a very interesting question. Mass of this is given, isn't it? So mass of the box is given. When a person was standing stationary with the box, no work is done or no energy is spent since displacement is 0. When he is running to catch the bus, kinetic energy. When he is keeping the load on inside the bus, when it is raised, that will be gravitational potential energy. Moving to question number 22. A bullet of mass 50 gram. 50 gram means directly you can write it as 0.05 kilogram. Is moving with a velocity of 500 meter per second. Okay. So let the bullet moves with an initial velocity of 500 meter per second. Since it is the initial velocity, I have given it as u. It penetrates 10 centimeter into a still target. That means displacement is 10 centimeter. 10 centimeter means 10 by 100, which is equal to 0.1 meter. And comes to rest. That means final velocity is 0. Okay. Now, so these are the things given in the question. First one, calculate the kinetic energy possessed by the bullet. So what is the kinetic energy? Kinetic energy means it is half mv squared. We have to consider the velocity only when it is moving, isn't it? So here, when it is moving, the velocity is u square. I think no use for this velocity, okay? So you can either put it as v. So half into 0.05 into how much is the velocity? 500, isn't it? So 500 into 500. Okay. Now with these two zeros of this 500, I will remove the decimal. So it will come as half into 5 into 5 into 500. I took two zeros from the first 500 and then the 0.05 into 100. That means you will be getting it as 5. Now, 5 into 5. How much is 5 into 5? It is 25. 25 into 5. We'll do one thing. We'll cancel this 2 and 500. So here you will be getting it as 250. This will be easier to do the calculation. Okay. So 5 into 5 is 25. 25 into 25 is 625 with the 0, 6250 joule. This will be easier. Okay. So with two zeros of this 500, I removed the decimal point. So it came as half into 5 into 5 into 500. 500 by 2 is 250. 5 into 5 is 25. 25 into 25 is 625. Now 625 and 0, 6250. Now one more question is there. The average retarding force offered. So what is the equation for force? Work is equal to force into displacement. So force is equal to work by displacement. So work means work and energy are same, isn't it? So it is 6250. And how much is the displacement? 0.1. Since decimal point comes in the denominator, what should you do? Multiply the numerator and denominator with the 10. So how much will be our answer? It will be equal to this 0.1 into 10 is 1. So the answer is 62500 Newton. Okay, so our answer is 62500 Newton. So we will move to the last question, that is question number 23. A spring is kept compressed by a small trolley of mass 0.5 kilogram. So a spring is compressed using a trolley lying on a smooth horizontal surface. When the trolley is released, it is found to move at a speed of 2 meters per second. What potential energy did the spring possess when compressed? So, a spring is compressed using a trolley. When it is released, what happens? The spring will move, isn't it? So, here we have the mass and velocity given and we are asked to calculate the potential energy. So, what can you say from this? The potential energy possessed by the compressed spring. When you are compressing a spring, it possesses elastic potential energy. This will be equal to the kinetic energy of the trolley, isn't it? So you are compressing the spring using a trolley. So when it is compressed, it possesses elastic potential energy. When it is released, this potential energy gets converted to kinetic energy and the trolley will move. So write the potential energy of the spring will be equal to of the compressed spring, okay? Potential energy of the compressed spring will be equal to kinetic energy of the trolley. So what will be our equation? Half mv square, which is equal to half into 0.5 into 2 into 2b square. This 2 and this 2 gets cancelled. 5 into 2 is 10. Since 0.5 is there, it is 1. So the answer is 1 joule. Okay. So with this, we completed all the 23 numericals. Simply don't copy the numericals. Please read the question. Try to do it by yourself. Okay. Else there won't be any use for doing the numericals. Okay then. Thank you, children.